Okay, we're in section 11 of the notes, and certainly what we're cover here is, it should be somewhat familiar to you, but it's going to look a little different. We're going to be covering basically the Gauss-Jordan elimination, but we're going to start talking more in a sense of like linear algebra type methods. All right, so we'll certainly start with the same stuff we had from Math 100. We're not going to change that story. Math 100, you did 2x2s. Right, you had consistent, inconsistent, and dependent systems in Math 100. That's not going to change. And certainly, depending who's teaching the course of Math 100, they might have said these things over here about interchanging two equations. The order in which you write the equation, that really doesn't make any difference. And, multiplying both sides by some non-zero constant. We're going to still do the same thing, all right? But what's going to happen, those things are going to look different, all right? So, for example, in Math 100, you had a system that looked like this. We're going to write it down this way. And this was called an augmented matrix. We'll look at that later. I'll go to the whiteboard later. We're also going to talk about a coefficient matrix. We're going to talk about a constant matrix. Again, we're going to relate to the original problem you have over here, and I'll review what you did in Math 100 to solve that system. All right. We're going to talk about, row operations, which is basically what you did in Math 100, but you didn't call them rows, you called them equations. Now we're going to call them rows. And we also have columns. Right, we have this augmented matrix thing, and we're going to be working with this. It's new to you, so it's going to see, why do I need to learn something new? We do need to move forward, and that's why we're learning new things, so I can move forward to even more difficult problems. All right, so I also go through a little bit of Sage code. I go through the method, and really where this excels, excuse me, is when we get what's called a 3x3 system. That's 3 equations with 3 unknowns. And it's going to be easier for us to deal with it. And read that, it reduces the amount of writing I have to do. All right. And we'll go through it in steps too. I'm not saying this is something that you understand yet. We'll get through it in steps. We'll go through those steps. And when we get there, we'll eventually get to the examples and we'll do the examples. But right now I'm going to go to the whiteboard. And just give me a second to do that. All right. Give me a second here. So what are we doing over here? So, my recommendation is you should certainly read through some of this material over here. But just to paraphrase, and maybe I'll read part of it too. But we're doing this Gaussian or Gauss-Jordan elimination. And so Gaussian elimination, also known as row reduction. It's an algorithmic linear algebra for solving a system of linear equations. And we want to do it, but I'll be honest with you, you've already been doing it. All right, you've already been doing it. Now, what have you been doing with it? You've been doing it with the 2x2 system, and we've seen this, and we'll take an example of that. So the method's named after a guy named Gauss, all right? Whoops. Right? That's a long time ago. And what I'm going to point out is that, it's kind of intuitive, but it's not intuitive until you start to try it a few times. And then it's going to seem second nature to you. However, I'm not going to say there's any kind of strict procedure you have to follow, except I'm going to say, like the fair and equal treatment. Like if you have an equation, multiply both sides by the same non-zero number. If you're going to add something to one side of the equation, add it to the other, blah, blah, blah. Teachers have told you Math 100, all right? Now, you're also going to hear the word Gauss-Jordan, right? And I want to point out, that's like our gold standard. We want to get to this gold standard of getting a matrix down, and we'll get to that later. And that's going to be what's known as reduced row echelon form, right? That's really nice if we can get to that stage, right? It's going to take time to get there, though. I'm not saying you're going to get there in a matter of minutes. It might take hours, weeks, whatever. It's going to take some time. We'll go through the details, though. We'll do it really simple, all right? So I'm going to talk about, what you were given in Math 100. You were given a 2x2 system. Now, what does that mean? You were given 2 linear equations with 2 unknowns. Now, how'd you do this? You did it graphically. You found out where the line to intersect. All right. You may have found the lines never intersect, or you may have found the lines were the same lines where they're always intersecting. And then they had words for that. All right. So let's point out what the words are going to be. Consistent means you have, where it says at least one solution, I'm gonna say have two lines, they would intersect at one spot. All right, intersect at one spot. All right. Okay, inconsistent. Now, what does that mean? That means the lines never intersect. Again, we're talking about two by two system. They never intersect. What's dependent mean? They're always intersecting. There's an infinite number of solutions in common, and for two lines in a plane, that means they're the same exact line. All right. So we over here is the basic of this Gaussian elimination. Just the basic part of it was essentially what you did in Math 100. It's no different. The method's no different. All right. Now, by the way, when someone says it's no different, you may see it as being completely different. I got to be honest with you, it's really no different. All right. So really what we're allowed to do, and I'm going to say you can interchange any two equations. Now, what does that mean? The order in which you write the equation down is completely incidental. Completely incidental. You can put the first one down, or if you want to put the first one down second, and vice versa. All right. The other things you did in Math 100, you multiply both sides of one of the equations by some non-zero number. Let's take an example. I'm going to remind you what you did in Math 100 for this particular example over here. And there's nothing wrong with what you've learned in Math 100. You can continue to do that if you want. Now, my goal over here is to learn something new, though. So if you were in Math 100, what would you have done over here? Well, if you didn't like the order in which the equation was written down, you could write them in a different order. Now, typically, I don't do that because I don't mind any order you put them down, like first equation, second equation, doesn't matter to me. But if you'd prefer, you could write this thing as, and this is interchanging a row. That's fine. You can do that. It doesn't change your problem at all. All right. I generally don't do it, though. I'll be honest with you. I don't do it. All right. Let me erase this business over here. And also about, the concept of, multiplying an equation by any non-zero number is not going to change the equation. Now, I got to be honest with our goal here, though, and you should be very well aware of what that goal is. Our goal is to produce a zero. So, for example, what I'm going to try to do is I'm going to try to get this to be opposite. So typically what we look for what's called the LCM. So the LCM, I'm doing the x's now, between 2 and 1. And what would that be? 2. So what I would do, I would multiply the second equation by -2. Let me go through that with you. And this is exactly what you did in Math 100. 2x minus 3y equals 7. And what do you get in the second equation? Minus 2x minus 8y equals minus 2 times just 4, right? And then what you do? You did addition. So in Math 100, your teacher might have called this the elimination method, or they might have called it the addition method. They actually might have said Gaussian. It doesn't matter, though. It should be intuitive to you how to do this. What do you get over here? Well, you get minus 11y equals 11, and y would equal, well, looking at it, it's -1. Now, you could play this game all day long. All right, let me go to the next one. I'm going to erase this business over here, erase this up here, and I'm going to get rid of the y's now. So I'm going to write down the LCM now between 3 and 4. And what would that be? 12. So I'm going to multiply the top equation by 4 and the bottom equation by 3. Now, some people say row 1, row 2. It's up to you. Let's go through that. What would that produce? Well, 8x minus 12y equals 28. Well, 3x plus 12y is equal to -6. Now, someone's going to say, do mistakes ever happen? Of course they do. We're going to check whatever we get to see if it's right. What would this give you? 11x. The y's would disappear. And then what do you get? You get 22. This seems pretty easy. X is 2. So I'm going to write down what I believe the answer is. I believe x is 2. We're going to write it as an ordered pair of numbers, and the y is -1. Again, this is an ordered pair, X, comma, Y. But again, I gotta be honest with you, I make mistakes. I want to see if I got the right answer. How do I do that? Plug it in. If X is 2, I would get 4, 2. Someone says, where are you plugging in? Always in the original, nowhere else. And if Y is -1, I get +3 minus 4. And if I did that arithmetic, I get 7 minus, did I make a mistake somewhere? Oh, I'm sorry. I think I made a mistake here. And I got to write it down now. Let me see. Did I do the first thing right? 2, 2. I did that. And 3 minus 4. Oh, I'm sorry. I'm seeing my mistake now. Yeah, I got confused. It happens, right? It's a mistake over here. What's that? What's 2 minus 4? It's -2. Does that work out? It's exactly what we expected to see, 7 and -2. So it's a good answer. I don't mind you doing that. All right, I don't mind you doing the method you learned from Math 100, but we do need to move forward. And this method here, although there's nothing wrong with it, it takes up way too much space. So we're looking for something simpler. All right, so let me go back on the notes. And what I'm going to claim over here is that I actually find it easier, right? Looking at this thing over here. We just did this problem over here. I actually find it easier to write this one down instead. And I'm going to do this one instead. But I want to point out, it's really the same thing we did before. All right. So I'm going to pull this into the side. And I want to see if I can do that. Maybe not quickly, but I'm going to pull this in the side. And I'm going to say this is a linear system with the understanding that I'm looking at this thing and I have to relate it back to the prior problem. And again, if you can't remember, look back over it if you have to. But I'm going to say this thing really says the same thing to me. What does it say? Well, let me grab it for you. It's this guy over here. I'll pull that over. Whoops. 1 second. And give me 1 second to pull it over. All right, push this over here. And pull this up here. And let me get this over here. This there. Push that away. Okay, I'm going to say that they read the same thing to me. So the first row, what I'm seeing, I want to point out what I mean by a row. This is the first row. I still read the same. It's 2x's minus 3y. This long bar over here is read as equals 7. I'm seeing that right here. You got to admit that this is much more compact though. What does this one say? 1x plus 4y is equal to -2. Exactly what it says over there. So what am I going to do? If you remember what I did in the past, I tried to generate zeros, or what's called an elimination. I'm going to write this down now for you, and it's going to take some time. So I'm going to write down what I did before, and I think I kind of remember. I think I took equation 1. I'll just call it row 1 now. And I multiplied that row 2 with the second equation by -2. I call it row 2. All right. Now here comes the tough part. I got to do it. Now, after I do it, what I'm going to do, I'm going to put it back into row 1 because I believe I'll be able to read it very simply, just like we did before. All right, so let me write this down for you. Row 1 is 2 minus 3, 7, and -2 row 2's is -2 minus 8, 4. And if you were to add those together, putting a line down to remind me, what would you get? 0 minus 11 and 11. All right, I'm going to write that down. Actually, when I write these things down, what other teachers do is they really start to do a lot more work. But I'm going to say, I think I know what this thing is saying. So it's going to be 0 minus 11, 11. So I did one lousy thing. What I do, I took row 1 and I added -2 row 2's to it. Whoops, I'm sorry, I gave it back. I made a mistake over here. This goes back to row 2. Sorry about that. I claim this guy's going to be really simple to read. I'm going to write down what I'm reading. All right, what I read is this. Minus 11y is equal to 11. What does this say? It says y is equal to 1. I'm sorry, minus 1. Must be tired today. What does the first line say? 2x minus 3y. Well, if y is minus 1, minus 3y would be plus 3 is equal to 7. So what does this say? It says x is 2. Now, why am I saying that? 2 times 2 is 4, 4 plus 3 is 7. So I can write down what's considered the gold standard, and this is that Gauss-Jordan form. I'll write this over here. We'll go through many more examples. What does the first row read as? So let me read it to you. It says x, no y's, x equals, what does x equal? 2. What does the second row read? No x's. Well, there's one y. What does y equal? Minus 1. This is our gold standard. Your calculator has this built into it. It can take a system like that and write this down very, very quickly. We'll certainly go through other examples. Some people say, I have more creative ways of doing this thing, and we're not saying you don't, but the end result is always going to be the same. What I'm going to claim over here is the original matrix we've written down, which is 2, 1, minus 3, 4, 7 minus 2, is identical to in information to the second one we wrote down, this one over here. However, the first one I really can't read. The second one I can read. What does it say? X equals 2 and y equals minus 1. Now, did we get that answer over here? We sure did. All right, let's go back to our notes. And we're going to talk about this in more detail. All right, so certainly we're going to give the name to these things over here. And let me just make sure you know what we're talking about. The matrix we're writing down is an augmented matrix. Right, we'll talk about what that looks like in more detail as we go through it. So it basically says you should make the connection between the augmented matrix and the original system of equations. We just did that through example. What did we look at? We looked at the original system of equations, and we made a connection with the way this is written over here. My claim over here, the matrix form is easier to write down. It's also pretty easy to read, provided I know what the variables are in the problem. We keep going back. We made that connection. It's important to note that the two forms are identical. Now, the one place they're not identical, if you didn't know what the variables were, they're not identical, shown with the variables. All right. It goes on to say about that, as long as we know the first column corresponds to x, and the second column corresponds to y. All right, it talks about the vertical bar. Sometimes the vertical bar is written down as a dash bar, but it's still vertical. It corresponds to an equal sign. All right. The last column corresponds to the constants. Now, instead of operating on equations, which we did in Math 100, we're operating on rows, but we're doing the same stuff. The same stuff. This is one I generally don't do, is interchange rows. However, there's nothing wrong with doing that. Sometimes people like to switch their rows around. You can do that. What is it like doing? Regarding the equations. You can do that. Multiply any of the rows by some constant non-zero number. I've been doing that for a long time. And what are you doing over here? You can add non-zero multiples one row to another. And you did that in Math 100. They just didn't call them rows, they call them equations. The claim about this over here is that the original system, which is this system over here, it's read as 2x minus 3y equals 7, x plus 4y is minus 2. We're claiming that this is the same information that's contained over here, but I got something that's really important. I got a 0. How's that read? 2x minus 3y equals 7. The second row is you simply read as y is equal to -1. We claim it's the same thing as this guy over here. Go through that. I want to claim, though, this is the gold standard over here. And I'll be honest with the reason for that. It's the zeros in the problem. Our goal is to obtain these things because once they're obtained, I can start reading it very quickly. What does it say? X equals 2, y equals -1. Here's the critical thing, though, and it's really critical. We're trying to get the diagonals to be 1. We're trying to get the diagonal to be 1s and everything else to be 0. That's going to take some time. That will take some time. Let's go to the next page. And I want to tell you about, if you want to use Sage, you're more than welcome to do that. You reset it, you enter the matrix, and you ask it to put it into reduced row echelon form. All right. So let's read this to you. It says a matrix that has undergone the process of Gaussian elimination, that's what you've been doing in Math 100, is said to be in reduced row echelon form. This gets tough. We're not going to memorize. We'll go through it. I'm not going to say in detail, but we'll go through enough examples that this should start making sense to it. All right. And I'm not saying it's going to be easy to read it or to understand what you're reading, but I want to point out our goal, again, is that diagonal of 1s, everything else is 0 in it to the left of the bar. All right. So what is over here? All 0 rows at the bottom of the matrix. All right. That's pretty understandable. The leading entry of each non-zero row after the first occurs to the right of the leading. That's word soup. All right. I'm going to tell you what that means to me. You got a diagonal of 1s and a bunch of 0s in it. The leading entry in any non-zero row is 1. All entries in the column above it and below it are leading the 1 or 0. Well, that's a lot of words. All right, we'll go through it. Okay, another common definition is row echelon form. Do not be overwhelmed by the only words we're throwing at you. I got to tell you, though, you're going to hear me say reduced row echelon form a lot. I like that form. I want to claim it's over here. Reduced row echelon form. But there's also this row echelon form. But again, I would look at it and say, do I really need to get all those definitions down? And no. But here's the deal. If reduced row echelon form is RREF, row echelon form should be REF. And calculators have that built into it as well. All right. I tend to prefer reduced row echelon form. Some people just like to get it in row echelon form. I wouldn't worry so much about that. My goal, by the way, is just to see if I can read the thing. All right. So let's take a look at an example. And they're telling me what to do, and I will follow their instructions. So my claim over here is I see the system, and this is the system of equations. Now, by the way, you can go back what you did in Math 100 and solve this thing, the techniques you did in Math 100. I got to be honest, it's too much writing for me. So what we tend to do is we tend to write down what's called the augmented matrix. So remember, this means it's equal. What's the first row read as? Well, provided I know it's x, y, z, the first row would be read as 2x plus 3y minus z is equal to -7. That's exactly what that first row up there says. What's the second row say? 3x minus 3y plus z is 12. What's the third row say? 2x plus 4y plus z is -3. Again, I want to point out what my goal is, and this might seem like a rather bizarre goal. My goal is this. I would love to see this in the end. With something here, there, and there. How would I read that? X equals, well, let's just say it was A. I don't know what it is yet. What does the second row say? Y equals, well, let's say it's B. I don't know what B is yet. What does the third row say? Z equals, I'll call it C. Our goal is to get it in that form, and then I'll be able to read it. I'll be able to know what the solution is. I'm not there yet. Get my eraser out. I want to follow their lead. And what are they asking me to do? I'll write it down for you. They're asking me to do this. Whoops, sorry about that. Okay, I'm going to write this down for you. And as I do it, it might be tough. It says row 1 plus row 2. I'm write this down for you. Row 1 is 2, 3, minus 1, minus 7. And what's row 2? 2, minus 3, 1, and 12. Now, someone says, why would they ask me to do that? I don't know. Maybe something nice happens. Nice things for me is, do I get zeros? Well, I get 4 here. Wow, I get 0. That's good news. I get 0. That's even better news. I got 2 zeros. And what's 12 minus 7? Well, it's going to be 3, 4, 5, right? You know what? I copied wrong. I'm sorry about that. The reason I say that, I know I copied because we got to get nice numbers. Let me erase this over here. I'm sorry about that. So first row was 2, 3, minus 1, minus 7. The second row was 3, minus 3, 1, 12. Let's put this down. This would be 5. This would be 0. This would be 0. And this is 5. And what they said, they said, give it to row 2. I'm going to put this little symbol here. And I'm going to give it to row 2. I'm going to do exactly what they said. What's row 2 now? 5, 0, 0, 5. Right. I want to do the next guy. And the next guy is this guy right over here. I want to see if I can do it. And what do they tell me to do? They tell me to take row 1. I'll write that down for you. 2, 3, minus 1, minus 7. And they said add it to row 3. What's row 3? 2, 4, 1, minus 3. When you add together, you get 4, 7. Yep, I want the 0. I'll be honest with you, I wanted that 0. And what do you get over here? Well, you get minus 10. Well, I'm going to write that down now. 4, 7, 0, minus 10. Now they did nothing to row 1, so I'll put this over here. 2, 3, minus 1, minus 7. But again, I want to claim what my goal is. My goal in the end, if I can, is to write something down that looks like this. Now, this is where a lot of teachers disagree with me. They say, oh, they should just keep doing row operations to get this. I don't think so. I'll tell you why. I'm just looking at it now. And I want to write down the easiest row for me to read, which is the second row. This is the easiest row for me to read. And what does it say? 5x, no y's, no z's is equal to 5. What does this tell me? X is equal to 1. That's pretty simple. So let me go back over here. And this is where I know what the X is now. What's the X? It's 1. I'm going to put that down now. All right. The second easy row to read is this one. And what does it say? I'll write it down for it. It says 4x. Well, if x is 1, 4x would be 4. Plus 7y is equal to minus 10. Well, it's more challenging, but I think I can do it. 7y is minus 14, right? Could take 4 from both sides, and y would be minus 2. Now, what does this tell me? It tells me this row. What does it say? Y is equal to minus 2. Let me do that down. All right. That top row is a killer, but we're going to write it down. If someone says, oh, yeah, you're interchanging the rows, indirectly I am. All right, let's write this down. 2x. Well, again, I'll circle these for you. What's 2x? 2 plus 3y. Well, y is minus 2, so that's minus 6. Minus z, I'm doing the top row, is minus 7. Let's see what happens. 2 minus 6 is minus 4. And what do you get there? Minus z. I'll add both 4 to both sides to get minus 3. So z would be 3, right? Let's see if we can put that down. And oh, that's the last row. Z is 3. All right. Someone's going to, it's a lot of work. I don't think I could do all that work. What I want to do is I want to see if it makes any sense though. So I'm saying X is 1. I'm saying Y is -2. And I'm saying Z is 3. I want to see if that's true. So I'm going to take it and plug it in. If X is 1, I get 2, 3, 2. If Y is -2, I would get -6, +6, I'm just plugging in, -8. If Z is 3, I would get -3, +3, +3. Let me do my arithmetic and see if it's what they say it's supposed to be. What do I get over there? -7. What do I get here? 12. What do I get there? Did I make a mistake? 2. Oh no, -3. Let's check it. I got it. All right. By the way, very small number of steps to get there. All right. Let's keep going. Okay. So I want to point out what they did over here was what I just talked you through. However, you're going to be shocked by this. A calculator can do this way faster than I could ever do it. This is the Sage code for it. And yes, we've talked about this. Reset, clear the memory out, define a matrix A. What's the matrix A? This is the matrix A. How's it being entered? Row, row, row. First row is 2, 3, -1, -7. The second row is 3, -3, 1, 12. The third row is 2, 4, 1, -3. Then what do? Ask Sage to do the reduced row echelon form. If you ask Sage to do that, Sage will spit this back as soon as you hit the enter key. It's that quick. All right. All right. That's it for the lecture. We'll go into examples next.